Hi everyone, welcome back. Mandar Chakrabarti here. Hope all of you are doing good. So, in the last video, we have had a basic discussion on vector arithmetic, which was the vector addition and vector subtraction. So, in this video, we want to continue on in that trend, and today I want to discuss with you the basic concepts of vector multiplication, which is vector dot products and vector cross products. So let's get started. Okay, so why exactly are we going through all of this trouble? Why exactly are we going through vector analysis again? Well, because when we are dealing with the world of wireless technology, we are dealing with electromagnetic theory, and electromagnetic theory is dealing with the motion of a wave. So as soon as we are dealing with motion of any sort of a physical process, we are dealing with vectors. So of course, a very detailed, very proper, very clear understanding of vector theory is essential to understand electromagnetic theory. Okay, so vectors, as we have already discussed, are a set of mathematical operators. So just as with normal scalars we can perform your simple addition and subtraction, in vectors also we can perform addition and subtraction. But as we saw in the earlier video, that the vector addition is slightly different from your normal addition because of the additional component of the direction, right? So we discussed all of that. So with a scalar value, we are able to perform multiplications, right? So same thing here with a vector value also, we can perform multiplication, but in vector values, multiplication is done in two different methods. So in case of a vector, we can perform multiplication in method number 1, which is your scalar product, or it is also known as the dot product, and then there is the second method, which is the vector product, and that is also known as the cross product. So let's go through them one by one. And again, I believe all of you are already aware of these processes because ideally the target audience for this particular tutorial series of electromagnetic theory are undergraduate students who are just presently either in their second years or in their third years. So for them at least, these topics are already covered. So anyway, we are just having a brief recapitulation of these concepts to refresh our minds about these things. Okay, so let's approach them one by one. We start off with what is the vector dot product. So vector dot product, mathematically at least, vector dot product is represented in this particular way. So vector dot product can be calculated in two ways. So the first way that we can do it is think of a normal number. Say for example, I consider say 10 into 5, and I will say that the result is 50. But when I am dealing with vectors, since we have two different directions associated, since we have two different directions of vectors associated, it is not as easy as simply 10 into 5. So with vector dot product, there is an angle which comes into play between the two vectors that we are trying to multiply. So the first step, the first way in which we can perform vector dot product is in this method where we consider the two vectors and we consider the magnitude of the two vectors and we consider the cosine of the angle between these two vectors. Essentially, the reason why we are considering the cosine of the angles between these two vectors is because we are taking the projection of one of the vectors onto the other. Let me elaborate it for you. So, if I were to take, say, two vectors like which are shown over here, so let me consider one vector. This one is my vector A, and I take another vector, say this one, and this one is my vector B. So, if I want to calculate, say, A dot B, which is the dot product of these two vectors, basically what I want to do is I want to take the projection of this vector onto the other vector. So, if the angle between these two vectors is theta, then at least this portion, this particular small bit, the projection of A onto B, this portion is given by what, if you can tell me all? Yeah, that's right. This is given by A cos theta, right? And now both of them are in the same direction. So now once I have gotten into my same direction, now it's no longer a problem and I can go ahead with the simple sort of multiplication. So essentially A dot B is something like B, or rather the magnitude of B, dotted with the magnitude of A and cos theta. So in that way, basically what we arrive at is denoted in this manner. Okay, so this is what we finally arrive at. That is how this particular formula has come to be. Okay, alright, now there is another way in which we can approach vector dot products, and let me show that to you. So the second way in which we can calculate a vector dot product is by considering, or rather breaking up the particular vector into its components in the direction of the primary coordinate axes. So as we were saying in the earlier videos, that since we are dealing with a three-dimensional world, and these sort of vectors, to simplify matters for us, these sort of vectors are two-dimensional vectors. So if I split up these vectors into their two primary coordinate axes, then I would get ideally something like this. Let me just draw that for you. So this is my starting point. So this becomes one axis and this becomes, this becomes the other axis. So you have x-axis and y-axis. Okay, so the way that we approach this is that we break these up into their components. So this vector, vector A, and this vector, vector B. So vector A and vector B, they have a certain amount of magnitude as well as a direction. So these directions are represented in their primary axes. So in the x-axis, the direction is represented by the I unit vector, and in the y-axis, it is represented by the j unit vector, right? So essentially, I can write this particular vector of mine, vector A. Let me write that for you. So vector A is ax, the magnitude, in I direction, plus ay, the magnitude, in the jth direction. Right, so in the same way, I can write my vector B as well. So vector B becomes bx, the magnitude, in I direction, plus by, the magnitude, in the j direction. Right. Okay, so now here, at least in this particular way, think back to the first method. What would be the result if I were to multiply I dot I? Then that would be, according to the first method, magnitude of I into magnitude of I into cos theta. What's the angle between the two of them? 0 degree. So that means 1, and these magnitudes are 1 only, right? So I dot I is 1. Same thing, J dot J is 1, K dot K is also equals to 1 if I consider the 3 primary coordinate axes x, y and z. What about I dot J? Let me write that here. So I dot J, so magnitude of I, magnitude of J, cos of, this time it's going to be 90 degrees in between the two of them, and cos 90 is 0. So we get 0. So now that we have got these two components down, basically what I can say is I dot I, J dot J and K dot K are possible. I dot J is not possible. Same way, J dot I is not possible. I dot K, not possible. K dot I, not possible. J dot K, not possible. K dot J, not possible, because these would only result in a 0 value. So, if I want to calculate A dot B, it is essentially AXI plus AYJ dotted with BXI plus BYJ. So what do we get? AX into BX and I dot I, which is possible, so that is 1, plus AX into BY, I dot J, so that is not going to give me any result, that's going to give me a 0, plus AYJ dot BXI, again I end up with a 0, and finally AYJ and BYJ, which ends up with a 1 product. So AY, BY, and finally what do I get? So A dot B is AX, BX plus AY, BY, which is the ultimate answer. Okay, alright, so now that we have understood what dot product is, now with the dot product you can see that this result that we got, this result is purely magnitude, right? There is no I or J component. So dot products, the result of a scalar multiplication of two vectors ends up with, surprise surprise, a scalar value. Can you try out one of these now? If you have understood the formula, then you should be able to solve this particular question. So why don't you give it a try, right? So try and solve this. Pause the video over here and try and solve this particular question. I'll give you the answer in a couple of seconds. Okay, so if you have actually managed to do this, then irrespective of whether you apply method 1 or method 2, the answer is going to be the same. So if you apply method 1, you will have ended up with this, and if you apply method 2, then you will have ended up with this. Okay, alright. So now that we have got an intuition of what the vector dot product is all about, now let's recollect what the vector cross product was all about. So vector cross product, and this one is known as your vector products. So vector product, of course, would mean that the resultant must be a vectorial form. A vector cross product again can be done in two ways. So the first method is the resultant is in this way. Let me explain. So in this particular case, when we actually consider cross products, what we do is we travel from one vector to the other vector. So if this is my A vector and if this is my B vector, then when I'm trying to calculate A cross B, then I am traveling from my A vector to the B vector along the shortest possible angle. So essentially I am traveling along this particular direction in this angle. So from here, one intuition that you can perhaps understand is A cross B is not going to be equals to B cross A. A cross B not going to be equals to B cross A, because if I want to calculate B cross A, I am traveling in this direction now. One other thing is, if you consider this one, then the other thing that you can perhaps understand is A cross B is ideally, it should be negative of B cross A. And I will show that to you also. Anyway, so A cross B is not equals to B cross A. Ideally, what it is going to be is A cross B is going to be minus of B cross A. Okay. And when we consider these two angles, we consider this time the sinusoidal of the angle between these two vectors. Okay, now the second method in which we can calculate cross products. So the second method gives us a result something like this. Now, one request, please do not memorize this particular result. I am just going to show you how you can calculate this particular result on the fly every time that you need to do this. So the way that we do it is, okay, I need a little bit of blank space for me to work on this. So, alright, clean slate. Okay, so two vectors, vector A is ax I plus ay j. In fact, let me this time consider three-dimensional vectors only. So axi ayj plus az k. Okay, and the other vector, B vector, is bxi byj bz k. Okay, alright. So to get the the cross product between these two, what we need to do is we need to calculate this determinant, which is I, j, k, ax, ay, az, bx, by, bz. And there are some sign conventions associated which are given by these. Okay, so let's take this step by step. So what we get first is A cross B is I, then ay bz minus az by. Okay, now next minus j. So I have minus j ax bz minus az bx minus az bx. Okay, and then finally the third component plus k, this time ax by minus ay bx. So ax by minus ay bx. Okay, so this is the final result and you can verify it. Oh, too much clutter. I'm sorry about that. Way too much clutter on this page. Anyway, you can verify that the two results are the exact same. Okay, now basically, since we have I component, j component and k component, so this result that we got, this result is a vector. So that is to say that when we calculate the cross product of two vectors, then the resultant is also a vector. So since the resultant is a vector, so that must definitely have a direction, right? So how do we calculate what is the direction of this resultant vector? Well, the direction of the resultant vector you will find is perpendicular to both the original vectors, and this direction is calculated using this concept of the right hand rule. So the right hand rule is basically something like this. If I were to consider that the index finger is pointing in the direction of the first vector, so index finger pointing in the direction of A, the middle finger pointing in the direction of the second vector, this is pointing in the direction of B, then the thumb gives me the direction of the resultant. Okay, so A cross B, this is the resultant. Now, conversely, if I were to calculate B cross A, right, so then B cross A, B cross A, the resultant is in the downward direction, right? You can see that. So A cross B in the upward direction resultant, B cross A in the downward direction resultant. Remember, we were just telling you that A cross B is going to be the negative of B cross A. So now you have your proof. Okay, so that was a basic introduction to the concepts of vector multiplication, vector dot product and vector cross product. Why are we again going through all of these things? Because vector analysis is very crucial when we deal with electromagnetic field theory, and it is going to be very essential in the upcoming portions. So that was it for this particular video. In the next video, we are going to dive even deeper into the concepts of vector analysis. So if you are interested in the world of wireless communication and how it all functions, basically if you are interested in electromagnetic field theory, then a sub to the channel would be really great, because we have a tutorial series which is going on right now on the concept of electromagnetic field theory. Okay, so hopefully I'll catch you in the next one. Bye bye.